Good afternoon, everyone. I'd like you all to welcome Brendan Darcy from the University of Sydney. He's here to talk about secure DevOps and shift-left security. Please welcome Brendan.
Good afternoon, AusCERT. Hope everyone's enjoying the conference. So my name's Brendan Darcy, and today I'm going to talk to you about secure DevOps and shift-left security. So first off, I'll just go over my agenda. So quickly, I'll just give a quick introduction about myself. I'll then talk about what DevOps is and the controls inside of the DevOps workflow. I'll then dig into 3 different stages, which will be the pre-commit, commit, and acceptance stage. I'll then talk about container image registry and golden containers. And then I'll finish up talking about operating models and the risk buy down of which we're looking to achieve by shifting our security model left. So like I said, my name is Brendan Darcy. I'm the lead solution and security architect for all the cloud and DevSecOps projects at the University of Sydney. I'm a ex-sailor. I spent about 13 years in the Navy. I hold several SANS and GIAC certifications, and I'm an AWS security specialist. Usually on the weekends, I usually spend it with my family. So DevOps, what is DevOps? DevOps is more than just a new software delivery methodology. It's more than the tools that wrap around this methodology. It is a mind shift and a cultural change, which means developers get closer to the user requirements, and operations teams and security teams get closer to the DevOps pipelines by automating their maintenance and security tasks. This will mean having to comply with a certain list of policies to be able to achieve this. This is where CALMS comes in. CALMS is a framework which allows organizations to assess the DevOps adoption when you're going through that initiative. So what it stands for is cultural, automation, lean, measurement, and sharing. So culture. So like I stated before, DevOps is all about the culture. And one of the main points of this is the collaboration between teams. So developers, application owners, the platform owners, and the security people all working together to achieve a common outcome. You then have automation. And automation is a very key part to be able to speed up that time to market within DevOps. Build, test, deploy, provision are all key starting points of this transformation. And what better way to actually start than having all the teams work together to produce a process of which benefits everyone. Lean. When I think about lean, I think about removing low tasks of which, how do I say this? Useless tasks, so to speak, and being able to continuously improve. Measurement and data. You're not going to be able to prove anything without the metrics behind it. Lucky for us, there's a lot of tools that allows us to measure this. So there's tools of which will tell you if your blog post yielded any sales. Looking at data which identifies the life cycle of a security vulnerability that you identified in code. The last point, sharing. Sharing is a very key point, and sharing really allows these teams to start moving agilely. The best example is sharing your constructs and your libraries in code. Allowing people to share those libraries really speeds up that time to market. Now, all of this together sets the framework of a experimental mind shift in a blameless way. It also sets that foundation for a concept, which is you build it, you own it. So on the screen at the moment, I have a general DevOps workflow. Now, this isn't just for developers anymore. This is for platform as well as security people. So in the top corner, I've got the developer. This is where the developer is working on his code locally. This is referred to as the pre-commit stage because he hasn't committed anything to the version control platform. You then have GitHub, which is the version control platform. You've got other ones as well, like GitLab. This is where you'll want to be setting up your branch strategy and your branch protection controls. In this diagram, I've got the dev branch and the pre-prod branch. This also happens in that pre-prod stage because it's just setting up that foundation to allow the developer to do his job. I then move across a little bit and down to the feature request. This is where the DevOps engineer has cloned the repo and it's created a feature. Once again, this is sort of in the pre-commit stage, is working on that code locally. I then move across a little bit to the pull request. The pull request is a request of which allows us to change code, initiate a peer review, or merge code. In this instance, I'm looking at doing like a peer review to make sure that there's the code follows those pre-approved constructs for the organization. I've then got the merge request, which merges the code into that development account. Across from that, I then have the subsequent pull request and merge request into the pre-prod system. This will then merge your code into that pre-prod system. And in between pre-prod and prod, I've got a manual gate. This manual gate can be set up a few different ways. For example, you could have a manual gate for absolutely every change, which probably isn't scalable because then someone has to be in there clicking that merge request. So usually you'll want to be looking at automating the process to allow standard changes to bypass this gate, where more major changes will be stopped and you'll need to approve that, that change to go into prod. So I've spoken about what the actual workflow looks like, so let's talk about some of the controls now. So we got the pre-commit stage. The pre-commit stage is where the developer or the engineer is working on the code locally on his workstation. This is where we have the rapid risk assessment. We have IDE security plugins, pre-commit hooks, peer review, and code ownership. I then move to the next stage, which is the commit stage. This is where the code has initially been committed into the version control repo. This is where we can start doing our initial checks, and this is where we've got the static code analysis, software composition analysis, dependency management, and container security. We then move to the acceptance stage. The acceptance stage is where we've got those, the code is looking at being deployed, and generally speaking, this is where the merge is actually happening. So we've got dynamic security tests, acceptance tests, and configuration management. After the acceptance phase, we move to the production stage. So the production stage is really talking about controls of which are set up by central security or operations team, which then allow different teams to move agilely. So it's all of those supporting features like golden images, runtime protection. You've got the secrets management here as well, which I'm talking about the setting up of the governance controls within a central governance team to define how that actually happens. And then down the bottom, I've got the guardrails for the accounts themselves. We then move to the operation stage. The operation stage is where generally most organizations live. We've got continuous monitoring, continuous compliance, threat intelligence, and regular tabletop exercises. So now that we've spoken about the controls, let's talk about the shift left security and what it actually means to implement these controls. So you've got our problem statements, which are weaknesses in the pipeline can lead to compromises of an entire application stack. If you're sharing your code and sharing your libraries, you can scale vulnerabilities across multiple teams very, very quickly, which is where the management of your cloud platforms comes in. And one of the last ones is with container and serverless technology, we're introducing that new attack vector. Last year, I heard a good saying, which was you can do DevOps in using normal virtual machines, but you can't use serverless and containers without doing DevOps. So I'm going to deep dive into my first stage, which is the pre-commit stage. So I'm going to try and start to the left as much as I can. So rapid risk assessment. This is a high-level risk assessment, of which is conducted up front by the DevOps engineer. You'll probably want two different risk assessments here. You want one which will establish the underlying risk for a new application, as well as a risk for someone that wants to conduct a sprint. So with establishing the first one, you want to be looking at and establishing that, that risk score. So you'll be looking at what is the attack surface? Is this application facing the internet? What other systems does it need to interact with? Does it need to interact with any other SaaS platforms? What's the classification of the data? And is there any high-risk code inside of this application stack? Where for established applications, you want to be working out if people are going outside of the guardrails of which have been predefined. So within the sprint, are they changing things like ports or APIs that need to be accessed? Are they interacting with new cloud services, of which will require additional permissions? This will then, going through this process, will establish the underlying risk and identify if the change or the new application falls within the guardrails, which is predefined by the organization. If it doesn't, additional reviews by cyber governance teams or by architectural review boards may be required. I've then got IDE security plugins. I'm not going to talk too much about this. However, in VS Code, there is heaps of plugins. So you've got SimGrep, which is a static code analysis tool. You've also got CNFNAG, which is another static code analysis tool. And you've got countless linting tools as well. You then have pre-commit hooks. Pre-commit hooks are hooks of which hook into the DevOps workstation or the engineer's workstation and will trigger like a script which will either help with formatting of the code or can conduct security testing before the code is actually checked in. The last two I've got here are peer review and code ownership. These sort of go hand in hand, and I'm going to dig into these two right now. So on the screen at the moment, I have a general branch strategy. I've got the dev branch and I've got the pre-prod branch. This is pretty much what I was talking about in the DevOps workflow. So in the first box, you've got the pre-commit stage, which is like that feature. You then have the pull request to do that peer review. You've then got the merge into dev branch and the subsequent pull request and merge into the pre-prod system. Now the stuff that you want to be looking at here and protecting is ensuring that this strategy is adhered to by the actual team. So protections that you should be looking at is preventing the deleting of the release branch. If you delete the release branch, you're not only going to probably lose work, but you're probably going to not be enabled to release anything to that account any longer. So that's really going to inhibit the ability for the DevOps team to actually move. The next protection is ensuring that those peer reviews need to happen. So to ensure this happens, you're looking at enabling the protection to make sure people have to follow that branch strategy of which is predefined. And this is all built into your version control platforms. It's usually different depending on what platform you're used, but generally they all have these controls. These are just two of the controls. There are a lot more depending on the product that you're actually using. So you're going to have to go read the docs and make sure you're implementing those hardening controls from that version control platform. So now let's push this one step further. So you've got code ownership. So this one specifically is from GitLab. So code ownership is a way for you to tag files for an individual, or files or directories for an individual to own. What this means is, instead of having people peer review the whole repo, if someone changes something to a particular file or folder, that individual will have to be a reviewer. It allows people to attach the SME for that certain file or directory. For example, if you're embedding security controls directly into your pipeline, you'll probably want your security team reviewing and making sure no one's changing the security scanning, making sure that they're not going in there and suppressing any alerts. So on the screen at the moment, I've just got the syntax of that. So setting this up is fairly easy. So all you need to do is create a code owners file in the either directory of which you want it in. The directory does matter, so you'll have to read the documents of the version control product you're using. And then you just need to write in the code owner's syntax your actual rules. So on the screen at the moment, I've got 3. I've just got all group members as a code owner for a file. I've got all subgroup members as a code owner for a file. And then I've got all group and subgroup members for code owner for a file. Down the bottom, I've just got a little snippet showing a repo which has a lot of code owners. This is usually an open source product where you've got volunteers that are changing that code and are usually allowed to do that. This moves me to the commit stage. The commit stage is the stage of which your DevOps engineer has committed the code into the version control product. This is where you can be looking at your static code analysis, and I'll talk about this in a little bit, but usually implementing static code analysis is usually really hard, and there's a few reasons for that. So sometimes it's really hard to find the individuals that understand how to implement these tools, and in other times, the code of which you're using could be fairly niche, and there may not be a big variety of tools for you to pick from. I then move on to software composition analysis. So even worse than your developers writing code which is vulnerable is your developers downloading open source code which is vulnerable. And this is what happened with Log4j. So the software composition analysis tool, it will actually break down the actual the open source software that's inside of that container. It'll create a catalog of those libraries. It'll take that catalog and then compare it to a vulnerability database, like the National Vulnerability Database. It will then output a report of all of your vulnerable libraries of which you have inside of that container. You can also do it for virtual machines. A byproduct of this is also what's called a SBOM, which is a software bill of material. This allows you to store and reference all of those libraries that are everywhere. So if you've archived all of your SBOMs really well, responding to something like Log4j will be a lot easier in the future because you'll just be able to identify where that library is and then go patch it. If you're using things like golden images, doing that will be really easy because you'll just download the new version of that container, and then the application developers will just rerun their pipeline, which will then apply the patch. You don't actually have to go in there and run any patching yourself. I've then got dependency management and container security. I'm not going to talk too much about these, but I will touch on golden images for containers in a little bit. So CloudFormation. CloudFormation is a great way for platform engineers to define cloud AWS templates to then deploy something in an AWS account. It works in a very declarative way, so the platform engineer doesn't need to worry about like CDK type syntax. They just say what they want and then it'll build it. They can also just as easily build these resources in a very vulnerable way. This is where CNF-NAG comes in. CNF-NAG will conduct a static code analysis and do a scan of your CloudFormation template. It'll identify things like weaknesses in roles. It'll identify if there's any wildcards in your actual roles. It will identify if there's any weaknesses within your security groups. It identifies if you're missing encryption or if logging hasn't been turned on. So on the screen at the moment, I just have a few commands. So it's pretty easy to run. You've just got the -- input path, which identifies the path to the CloudFormation template. I then have the -- output format option, which just allows you to output the report how you want to see it. So the default is freeform text. I then have the -- debug and -- help, just for reference. Down the bottom, I've got how easy it is to run this tool. You just need that -- import - path command. One thing to note is I am showing you just a command line version of this. You'll still need to embed this into your pipelines to make sure that it's running automatically every single time that your developer or DevOps engineers update their application stack. So this happens all the time. The next one I've got is dependency checker. So In the 90s, developers realized that they could really speed up their time to market for their releases of their applications by sharing their code. This is where the popularization of open source libraries actually started, and developers really started to share their libraries widely. This is where dependency checker comes in. So dependency checker is scanning for that open source libraries to identify what's actually there. Like I mentioned before, it just runs through a process of cataloging it, comparing it to a database, and spitting out a report. On the screen, I've just got the basic options of which you'll need to run this. So you've got the -- scan path, which is once again just the path to the actual file that you'll need to scan within the virtual machine or the container. You've then got the -- format, which will then be able to pick the format of which you want to output your report as. You can choose multiple formats with this tool as well. Down the bottom, I've just got a basic example of how to run dependency checker. It's pretty easy. You just need to point to the file of which you need to scan. In this case, I'm using the ant style path to then point to the jar file. This brings me to the acceptance stage. The acceptance stage is where you're pushing your application into the actual environment, and you're running through all of your acceptance testing. And you really want to be doing that automatically and doing it real time as the developers are pushing their code and running their pipelines. So the first one, I've got dynamic security testing. So this is where you want to run your DAST scans. So when you run a DAST scan, what you're effectively doing is you're checking the vulnerability of that website from the external. So you're achieving very similar of what a pen test team or a red team would actually be achieving. This leads me to the acceptance test. Acceptance tests come in a whole different list of different types. You have unit testing, functional tests, you have end-to-end tests. And this brings me to the configuration management side of it. So I'm going to talk about in a minute a cloud management platform, which you can actually look at automating a lot of those fixes and a lot of those misconfigurations within your cloud account. You can then look at embedding that tool into your pipeline and having this run real time as well. I will touch on one main one, which is your AWS SHA playbooks. And the other one that I'd like to mention is Cloud Custodian. Cloud Custodian is a free open source tool. It is funded by Capital One over in the States. It is a cloud agnostic tool. It will run across AWS and Azure. And they've just released, I think, the beta for GCP. What this will actually do is you'll be able to create policies of which will rectify vulnerabilities within the platform. You can also take those templates and you can actually put them into the pipeline and run them real time in the platform as that pipeline is run. So this brings me to OWASP Z attack proxy. So this is one of the, or the most widely used DAST tools that are out there. So ZAP, you can run two different types of scans with ZAP. You can run a passive scan, which will just passively listen to the application. And then you can run an active scan. An active scan will actually actively send packets to the application, and then it'll figure out if there's any odd errors or outputs, and then it'll create a report based on that. There's a few different ways to set up your Z attack proxy. So you've got the command line version. You've also got an API version, which will scan stuff like OpenAPI, Swagger, and stuff like that. You then have a Docker version. And the Docker deployment, I think, is key to running your DAST tool or the attack proxy inside your pipeline. So what you can do is you'll spin the container up, you'll then do your DAST, you'll then destroy the container, and you'll do that all inside the pipeline. Down the bottom, I've just got the basic command to run ZAP. There is a few different scanning that can actually happen down here. You got your baseline scan, which is just doing a passive scan. You have your active scan, which will do a active scan and will continually spider. You then have your, like I said before, your API scan. On the screen at the moment, I just have a basic report. Down the bottom, you can just see that the report's triggered a couple of warnings. So cloud management platform. So on the screen at the moment, I'm just showing a basic flow of what's happening within the SHA playbook. I've taken this straight off of AWS. This is a solution of which AWS provides for their customers. You can just grab it and then implement it in your environment. What it allows you to do is remediate and automatically remediate findings from CIS and AWS benchmark findings within Security Hub. It will also do it in a multi-AWS account setup. So as you can see down the bottom, I've got one account, which is AWS Security Hub is then talking to the central account, of which finds all of the CIS and AWS benchmark findings. That then feeds it into a event bridge within CloudWatch, of which you can automate this remediation, or you can do it manually within a Security Hub, and you just need to click the finding, click up on the top right, and then remediate with SHA. All of these playbooks are already predefined. AWS writes them all for us. So that's where you've got the remediate and the Lambda function, which then goes across accounts to then remediate whatever findings you've identified and that you want to fix. It's then got the logging, which talks about the Amazon SNS notification, and you've also got your CloudWatch logs. A good thing with this solution is if you're not actively running this solution, it doesn't cost you anything. So AWS is based on Lambda functions. Unless you're actually using your Lambda function, it's free. So this solution can sit there and not be used, and it's free. But if you start using it, it'll just start to cost a little bit of money. So this brings me to golden container images. So up the top, I've just got a basic DevOps flow. As you run your containers through the flow, you want to be identifying certain things as you put these containers into your environment. And what you're trying to achieve here is you want to buy down that supply chain risk. So you want to ensure that containers are only downloaded from approved public repositories. The best way to control this is through pre-commit, because there's no real commit controls of which you can do this nicely. You then want to scan for vulnerabilities. You want to be looking at scanning these vulnerabilities inside the pipeline itself. The reason why is because you want to fail the pipeline if it actually doesn't meet the requirements of your organization. For example, if there's log4j inside that container, you probably don't want it getting into your Elastic Container Registry. So you probably want to fail that at this point in time. This moves me to malware scanning. Obviously, you just want to scan for malware, make sure no one's put any backdoors inside that container. This brings me to immutable tagging. So immutable tagging is just a checkbox, which means that people can't override the containers of which you actually put into your registry. The thing that you're looking at preventing here is poisoned images. So if someone takes over your registry, people can't override that container, and then the DevOps team will then just download the container without knowing it, and it's got a backdoor in it. This then brings me to signing of the container. So after you have brought down the supply chain risk, you want to sign the container. The reason why you want to do this is any container that is not signed, you don't want to allow your developers to use. So you sign every container. A good tool for this is cosign. This brings me to the admission controller. The admission controller is a shift right in security. It is basically a hook which sits in between the signing of the container and the developer downloading and using and pulling that container to use in the environment. So within that admission controller, you will identify if the container is signed. This is really important because if the container isn't signed and they try and use it, this will fail them every single time. So if they haven't gone through the right checks and balances, they will not be able to use their container. You then have the last box, which is just continually scanning for vulnerabilities of those containers within the environment. And the reason why this is important is if you want to scan the runtime environment, you probably have to go to a vendor to get something like a pod to run in the actual host itself to be able to identify those vulnerabilities in the runtime environment. In this method, you scan the vulnerabilities inside the registry, and then you identify which containers have fallen outside of your guardrails, and you'll need to identify where they've been pulled to and where the developers have used it, and then ask them to restack with a new container which have those vulnerabilities fixed. I believe all of these controls together are really buying down that supply chain risk. However, there is other things to do inside of this chain. So I haven't spoken about linting for Docker containers. So I've left out header lint. I've also left out static analysis of the actual Docker file itself. The reason I did that is because I believe these are the primary ones to buy down that supply chain risk. So let's recap quickly. So we've got the pre-commit stage. The pre-commit stage is the stage of which the developer is working on the code locally on his workstation. You've then got the commit stage. The commit stage is where the developer has committed his code into a version control product, like GitLab. You then have the acceptance stage. This is usually where the application stack is being built out in your environment. Production stage, this is where centralized teams are providing, supporting application stacks like golden images and everything. You then have the operation stage, which is just looking at that, the operations of continuously monitoring and the continuous compliance of all of your environment as well as your application stacks. So how do you scale this? And what does the operating model look like? So on the screen at the moment, I just have a basic operating model which identifies the golden standard of a DevOps team. The golden standard is a DevOps team owns the application, the platform, and the security scanning. This is generally how organizations like AWS and Google actually set up their DevOps teams. However, is this really scalable for every organization? Most organizations are set up in silos where the application team is one team, the platform team's another team, and then you've got the security team which is doing their thing. So that brings me to option 2. So option 2, you have a central security engineering team. They will own the implementing of the SAST, the SCA, and the DAST scanners. What they'll need to do is they'll need to go into every single pipeline and put these scanners inside the pipeline. So SAST, SCA, they are a pre-build scanner, where your DAST is a post-build scanner. This is very time-consuming, yeah? Because security personnel are going to have to go into every single pipeline and put the scanners inside that pipeline. So that brings me to option 3, and it is to automate these tools running. So basically, you'll be looking at a security engineering team which is triggering these scans based off of an event within AWS, for example. You're looking at code build. So once something triggers a code build, it will then trigger a certain scan. Once the application has been built out, that'll then trigger a DAST scan. So a good example of this is the golden images for containers. You can centrally manage all of that pre-build, build, and post-build within one pipeline, and developers can push and build their containers as they want to, and they don't need to worry about what's being scanned. The security team just worries about configuring that scanning tool to block the containers that they don't want to see go into that registry. So this brings me to what risk buy-down we're actually looking at. I'd like to give a shout out to the Verizon Data Breach Investigation Report. It's a great place to go to identify the stats of what's actually happening within a certain region or within a certain sector within the market. So on the screen at the moment, I just have the APAC region. So as you can see, the biggest hit is from social engineering. You then have basic web application attacks, system intrusion, miscellaneous errors. So shifting your security model to the left and putting your controls into that pre-commit, commit, and acceptance stage won't really help you too much with the social engineering side of it, but it will definitely help you with all of the other sections. So this brings me to Log4j. What's going to help you with Log4j? Your software composition and analysis. It's going to identify those insecure libraries and tell you what vulnerabilities that you've got there. Byproduct of using that is going to be the SBOM. So then when you want to respond to the future Log4j, you'll be able to easily identify those vulnerabilities, use the golden image for containers, and then easily update and patch your entire stack. Another one, exactly like Log4j, you've got web logic. Another one which is going to be reliant on your software composition analysis. Capital One. So Capital One got done a couple of years ago. They got done because they had metadata version 1 inside of their EC2 instances. The SHA playbook will help you with this and be able to auto-remediate these findings. The second point is they needed vulnerable EC2 roles to be associated to the EC2 to be able to see every single S3 bucket. So if you actually restricted that role down, you'd be mitigating some of that collateral using something like CNF-NAG. This brings me to the Optus breach. So it doesn't worry me how the Optus breach actually happened. Let's say they got in through phishing. What's the first thing that an attacker is going to look at doing? They're going to be looking at, they have a poke around, they'll look to escalate their permissions, they'll then move laterally. They'll then have a look and see what they can see with those new permissions. They'll then try and escalate their permissions again, and then move laterally. Shifting your security model left will allow you to address those moments of which attackers are trying to pivot within your environment, so that escalating of the privileges and moving laterally. Medibank, exactly the same as the Optus data breach. They're going to be looking at escalating their privileges, moving laterally, of which shifting your security model left will help you. If you get done and get breached, you're probably looking at a $50 million fine these days. However, what's worse than the $50 million fine is the direct right of action. This is a recommendation which came out from a review of the data privacy law. What it actually states is individuals that have been inside of a breach will have the right to take that organization to court. Imagine your organization getting a class action lawsuit from the whole customer database. Pretty scary stuff. This brings me to the organizational risk appetite. So down the bottom, you've got the operations and the production stages down the bottom, of which are known, they're assessed using scanning tools like Qualys. You've got things like cyber governance happening here and cyber review boards. However, they're only looking at paper documentation, so they're not really looking at the code and identifying those vulnerabilities that are truly in your environment. You've also got red teaming in this section. Red teaming's a funny one, because the whole point of DevOps is to move rapidly, to be able to push out heaps and heaps of updates. So if a pen test takes 1 week to plan, 1 week to execute, 1 week to write the report, and the DevOps team has rebuilt their application, 5 times every single day? Does that report actually reflect what the application is? That is why you want to be looking at doing this stuff real time. Up in the top, I've got the pre-commit, commit, and acceptance stage. This is where you're doing your static code analysis. This is where you're doing your software composition analysis and your DAS scanning. So, former Chief Security Officer of Uber convicted of federal charges. I read the other day that he's looking at getting 5 years. So, I'd like to leave you just with one thought is, if your organization is doing custom code, using containers or serverless technology, or you're a heavy DevOps organization and you haven't moved your security model left, are you negligent in applying any controls? Thank you very much. That's my talk.
Thanks, Brendan. It's really great. Actually, there were a few questions, but we're sort of out of time. The questions were, I guess, tips for encouraging adoption. Another question was, how can they hire you as well? So anyhow, but contact you, mate. So maybe if you want to catch Brendan later, you can use the conference right the rest of the day. Yeah. Anyhow, thanks, Brendan again. He's a little present from AusCERT.
Cheers. Thank you.